Welcome, I am Eduardo Berrocal from Intel. In this video, I present an introduction to the Low-Level Persistent Library, or LLPL, an open-source Java library being developed by Intel for persistent memory programming. LLPL provides Java access to persistent memory at a memory block level, giving developers a foundation for building custom abstractions or retrofitting existing code. LLPL complements Persistent Collections for Java, or PCJ, another open-source library being developed by Intel which emphasizes persistent collections and provides higher-level functionality such as garbage collection. LLPL gives us two main abstractions: persistent memory blocks and transactions. Persistent memory blocks are exactly what their name suggests. That is, a continuous block of memory carved out of a persistent memory heap. Under the hood, this persistent heap is actually a memory map file stored on a persistent memory device. We can create and open a heap using getHeap. In LLPL, there are three types of blocks: raw, flashable, and transactional. Objects created using these classes are in reality reference objects. They live in volatile memory. The actual data block resides out of heap in persistent memory and needs to be allocated as well as destroyed explicitly. Persistent data block allocation and destruction is easy thanks to the allocate memory block and free memory block methods provided by the heap class in LLPL. Similar to PMDK and to PCJ as well, we need a common root block to anchor and later find all the other blocks created inside a persistent heap. You can think of the root as the entry point. To set a block as the root, we pass its address to the setRoot method. To retrieve the root, we call getRoot, which gives us the address of the block. The memory block object is recreated by calling the memory block from address method. Realize that this method does not allocate new persistent memory. It is simply recreating the reference object. Data access in LLPL is done using a set of accessor methods in the form of getters and setters for the basic types byte, sort, int, and long, as well as general memory copy operations. Getters expect a byte offset relative to the beginning of the data payload of the block, and work identically regardless of the block class used to create the block. In the case of set methods, behavior depends on the class used to create the block. For raw blocks, data is simply written to the destination. For flashable blocks, data is written and the modified addresses are added to an internal list. This list is later used in order to know what addresses should be flashed when the method flash is called. Flashing ensures that all pending writes remaining in the CPU caches are safely written back to the persistent memory device. Finally, transactional blocks write the data atomically using a transaction. This atomicity is key when we need to group multiple operations that need to happen all at the same time or not at all. Transactions are key to ensure that we don't end up with corrupted data structures when carrying out sensitive operations such as moving internal pointers. LLPL is open source and available in the links provided. You don't need specialized hardware to start using and transforming your Java code for persistent memory today. If you want to learn more, I urge you to access the documentation, also provided in the links. Thanks for watching. Don't forget to like this video and subscribe.